Hey Gracies, I'm going to take you back here today with another wonderful equation, which is an epic equation called as the Bernoulli's equation. And the Bernoulli's equation mainly deals with the elevation as well as density and pressure and velocities of a flowing liquid. Bernoulli's equation, it is applied in the air as well as in the water or wherever we can take it. Okay. And now I'm going to introduce you the terms or the specific alphabets used in the Bernoulli's equation firstly. I'll tell you Bernoulli's equation. P1 plus rho GH plus half rho V squared. This is the Bernoulli's equation. And you can see yourself that P stands for pressure and I'll write it here. Pressure, rho stands for density, and G stands for acceleration due to gravity. And V stands for velocity, and H stands for elevation or height. Okay. This is a kinetic energy because we can see that it's a velocity squared. So we can consider this as a kinetic energy in this equation. And this is a potential energy. Potential energy. This is pressure. This can be static or anything. Okay. So this is a Bernoulli's equation. And then these three terms, that is pressure plus rho GH plus half rho V squared, when added results in constant. Because when these all terms add up, we will get all these will result in constant. And now this video mainly focuses on the Bernoulli's equation applied on the aeroplane. And I will show you an example question for it. Okay, now let's go for it. Before that, let me tell you something about aeroplanes. And since this is an aeroplane, this doesn't feel like it, but just for you to see, okay? So, don't be serious in this. I'm not a good rower, you know. Okay. Huh, it's better. Okay. Now, what I'm telling about this, the wings of aeroplane is in a slanting manner, right? So we can see this in a slanting manner. When this aeroplane moves in a streamline or through the air, we can see that the air molecules obstruct mostly here. Most air molecules have been obstructed here than this, because the air molecules we strike here go scattered, won't stay there. These molecules won't stay there, but more air molecules will be obstructed at the bottom part than the top part comparatively. So we can say that now the velocity is the inverse relation between pressure and velocity. Do you know that? Pressure is equal to 1 by velocity, or velocity equals 1 by pressure. Because when the pressure increases, tell me where the most pressure is experienced in the wings of the aeroplane, the bottom part, right? Because of that, more air molecules obstructed there. So we can say that the pressure on the bottom part is greater than the pressure on the top part. So when telling about the velocity, we can say that because there is an inverse relation between pressure and velocity, so velocity on the bottom part is less than velocity on the top part. And that's it. This is it. Okay. I think you got what I said here. Now let's go for a question. I'll drop this. Let me draw another aeroplane because I need to demonstrate to you what I'm telling in the question. Now let's go for the question. Find the pressure difference that is occurred in an aeroplane. This is an aeroplane. While traveling with velocities of two velocities are there, 170 meters per second and 134 meters. Okay. If the density of the plane is 1.29 kilogram per meter cube, and the area is 50 and 50 for each wing, find the weight and for force also. Okay. It is set as firstly 179 meters per second, and this as 134 meters per second. And this is the density of 1.29 kilogram per meter cube. And now 50 meter square for this wing area, and also this wing has 50 meter square. And it is said to find the pressure difference. That means P2 minus P1, because change in pressure means the P2 minus P1 only we can say it as a change in pressure. So now let's go. Pressure and everything, right? So we're gonna taking these two equations by comparing each other so that we can get the variation in pressure or the pressure difference experienced between them. Plus rho GH plus half rho V1 squared, this as H1, okay, equals P2 plus rho GH2 plus half rho V2 squared. I think now it's fine. You can see it yourself. And we need the variation in pressure. That means P2 minus P1, or the change in pressure. So we can take it as P2 minus P1 equals. Before that, I need to tell you something. This rho GH1 and rho GH2 gets cancelled. Do you know why? There is only a slight thickness between the wings of the bottom part of the wing and the top part of the wing. So when taking this height, so what is a 90 meter or something like it, and into G 9.8 meter per second square, into density as something, and when these all get multiplied, and when these all also get multiplied, these are all having the similar numbers, right? So if it is like 980 and this also has 980, then this plus 980 and this minus 980 when coming to this plus 980 also, and when this plus 980 gets to here, then both these terms gets cancelled. So we don't want to have that much procedures to do, so that we can cut it by here itself. Okay. P2 minus P1. Now let's come back to where we were. P2 minus P1 equals half rho V1 squared minus half rho V2 squared. I think this won't be visible to you, so let me do this once more so that this will be visible to you clearly. Half rho V1 squared minus half rho V2 squared equals P2 P1. Now P2 minus, therefore P2 minus P1 equals half. We can take half rho as common because these half and rho are common for both these terms, and bracket, at bracket we can write it as V1 squared minus V2 squared. And P2 minus P1, that is delta P, we can write it as delta P, which means change in pressure. That's also perfect, and I'm gonna write it as half into rho means 1.29, which means the density, right? 1.21 into V1 squared. V1 is 179. 179 into 179 or 179 square minus V2 is 134 square. This is it. And when this pressure is, the change in pressure is calculated, there is a small procedure of multiplying. Now let's multiply. Now we're going to multiply it 179 into 179 and 134 into 134. Now I got it as 14085. So half into 129 by 100 into 14085. And now let's go for multiply. It's slightly a difficult procedure, okay? But whatever it is, I should go for it, right? If you're in exams and all, who is gonna do for you, right? 14085 into 129. There's a lot of procedures in this. And 72, 72, 75, 0, 4, and 77, 88, 10, 50, 1, 7. There's now. Okay, I got it. It's 9805. 9805 Newton meter squared, and that's the last answer. So this is it. This is so much simple. Look at it. Only the thing is, you will be having a slight difficult problem of multiplying and all. And the second thing is to find the force also. Force. Do you remember the force equation which deals with the pressure and which is having the pressure times it? Do you remember that? Pressure equals force by area, right? Do you remember the equation that we studied in all the classes? And so now it is said to find a force, right? Force equals change in pressure into area, which is the equation from which we have to find the answer. The pressure is 9805 Newton meter squared, and the change in pressure, so that's it. And now we need to find the force, right? Which is 9805 Newton by meter squared into area is 50 meter squared plus 50 meter squared. Both these means area is 100 meter squared. That's it. Meter square gets cancelled, and now force equals 980,500 Newton. That's it. It's so much simple. And you'll find it yourself. You'll be so amazed that when you get the answers of this. I think one more thing is yes, find the weight also, and if the mass is 5,000 kilogram. Weight, I remember the equation of weight. Weight equals mg. So W equals mass means 1,000 kilogram into 9.8, which is 98 into 5. 5 is a 40. 5 is a 45. 49. 49. And 10 will be gone because of the point 149,000. Kilogram, and that's the weight. Simple. And that's it. I hope you guys came to know what's the Bernoulli's equation and how we are applying that Bernoulli's equation in the aeroplanes. Firstly, I told you about some conditions that you should not forget that conditions, because those are the fundamentals when applying Bernoulli's equations in the aeroplanes condition. And I hope you guys enjoyed my session. If you like this video, then leave a thumbs up in my video, and don't forget to like and subscribe. Okay, signing off from THUMPS, and see you guys in the next video. Till then, bye bye.